Hello everyone, this video is about differential equations. Equations involving differentiation such as dy dx called differential equations. Separable because we can make the same letter on each side. So for example, dy dx equals x squared y cubed. We can divide by y cubed and multiply by dx. We get this equation. We can solve it by integrating both sides, and the answer or the solution is an equation. So the solution to this equation is an equation. There are two types of solutions, general or particular. General means still with the constant of integration. Particular means after we find the value of that constant by plugging in some values. So for example, you have this equation when x equals 1, y equals 2e. If we integrate 1 over y becomes ln, and 3x squared becomes x cubed. We have constant. We can just move this c1 to the right. We have c2 minus c1, which is another constant. We can call it c3. And we can erase both sides with the base e, so we cancel out e and ln. We have only modulus of y. We have e to the power of something, which is always positive, so we can lose the modulus sign, no need. And we have e to the power of x cubed times e to the power of c3. E to the power of c3 is another constant. We can call it c4. This is called the general solution because we still have c. And after plugging in, replace the y with 2e, the x with 1. We can find the value of a, and therefore the final answer is from here. We replace the constant with 2, which is after plugging in. This is called the particular solution. A past paper example. We have this equation. We have the boundary condition. We need to solve, express in make y squared the subject in terms of x. So we can start by dividing both sides by y squared plus 5. So we move it like down here, and we divide by x plus 1. So we move it down here. We get y over y squared plus 5 dy equals 1 over x plus 1 dx. Integrate both sides. We need to adjust here because we need this numerator to be exactly the derivative of y squared plus 5, you know, that ln rule. And now we have the integral, which is simply ln the denominator, and here we have ln the denominator, and just use the constant ones on the right and multiply both sides by 2, and we can, yeah, this is called c2 because actually we have to multiply this by 2. We have 2c1, just call it c2, and we can move this 2 inside the logarithm, so it's something squared, which is always positive actually. And we can raise both sides with the base e, cancel out. We have only modulus of y squared plus 5, and e to the power of ln also cancel out. We have only this is always positive, no need to use modulus. The right hand side is always positive, so no need to use modulus. And we have e to the power of c2, which is we call c3, and we have just a constant. We can just call it a. This y squared equals, move it to the right, we have minus 5. We can plug in the boundary condition when y equals 2, x equals 0, and we can find the value of a. After we find the value of a, plug in to this line here, the a is 9. We get the final answer. This is the particular solution. The hardest part probably in differential equations is to convert the English into mathematics. So for example, if you see the phrase rate of change of something, that's d something with respect to the denominator, what it dv dr in this example. If you see only rate of change of radius without with respect to something, so that means automatically that's with respect to time. So rate of change of radius means dr dt. Proportional to x means equals k times x. K is just like a multiplier or just a constant, and inversely proportional means something like k times 1 over x. So for example, here we have this question. We can just read it first. We need to form a differential equation. Alright, so first of all, we know that from the question, we know that The volume of a cuboid is base area times height. The base is a constant, it's always 2. So 2 times the height, you can just call it h. This is h, by the way. So this is the water level, the depth of water, h. When time equals 0, the height is 0. When time equals capital T, the height is 4. So here, when time is capital T, the height is 4. So dv dt is therefore equal to, because we have flow into 1 and flow out from 0.2 root h, so it's plus 1 minus 0.2 root h. And dv dt is, using chain rule, dv dh dt. The v is actually 2h, so d dh of this, we differentiate 2h with respect to h, we get simply 2, and dh dt is therefore this. We can now divide the throughout by the right hand side, or we move this down here, and there's nothing here, just 1 multiplied by dt, so it's just dt. And here we multiply by 5 over 5 to get rid of the fraction, so we have 10 over 5 minus root h. And when we integrate, we get the integral of nothing dt, or basically the integral of 1 dt, which is just t. Plug in t, plug in 0, so it's just capital T equals this, which is what we need to prove. And then using the substitution, u equals 5 minus root h, so this is just integration by substitution. We're not gonna go over this, we've done this before. Alright, now if we are translating the maths into English now. So let's say we have this result from the differential equations, and we know that as t approaches infinity, x approaches 5. So this means as t becomes large, the x approaches 5. And here if we plug in t equals infinity, e to the power of minus infinity is just a 0, or just use your calculator, replace this t with something big like 1000 or 999. If it's too big and you get an error, try something smaller, you'll get a 0 basically. And after a long time, concentration drops to 0. This is the English. And if we have this kind of graph, you can interpret this graph as the maximum number is 37, which is the horizontal asymptote of an exponential function. Last example, you can do the question first. Form a differential equation in y and t, and so dy dt is from here minus 0.2 xy, but the x is 10 over 1 plus t all squared. So we replace this x with 10 over 1 plus t all squared, and we can divide by y, multiply by dt. We get 0.2 times 10 is 2. This is 1 over, so to the power of minus 2. And the result is 1 over y becomes ln, and this becomes minus 2 times 1 plus t all to the power of minus 1 divided by minus 1, which is just 2. And we can do e to the power of, cancel out the ln, always positive, so no need to use modulus. And we have a constant, let's call it a. Plug in the boundary conditions, when t equals 0, y equals 100, we get the value of a, and therefore this is the solution. We can use this form or this or this, they are all equivalent. And now part II, find the exact value by the mass of b as t becomes large and as a becomes large. So when t approaches infinity, for the mass of a, which is the x, when the t is infinity, we have 1 plus infinity, which is infinity. Infinity squared is still infinity. 10 divided by infinity is 0, so x equals 0. And the mass of b, which is y, as t approaches infinity, we have 1 plus infinity, which is infinity. 2 divided by infinity is 0. 0 minus 2 is minus 2, so we have 100 e to the power of minus 2, or 100 over e squared. So this is what we mean by interpreting the equation or the maths to the context of the question. Alright, that's it. I'll see you again next time.